In this example, we are going to determine the cardinality of a set. If the universal set S has 103 elements, and A and B are subsets of S, set A contains 48 elements and set B contains 94 elements. If sets A and B have 30 elements in common, how many elements are in neither A nor B? So the first thing we need to talk about is what we're trying to find. We're trying to find the cardinality in neither A nor B. So neither A or B means that we are looking for the number of elements not in the union of A and B, meaning the complement of A union B. Again, we're looking for the number of elements because it says how many, and this is cardinality. So that means our answer will be a number, not to be confused when we list elements. Great, so now we know what we need to find. The second piece of information we need to note is a cardinality formula. We know the cardinality formula that's in the textbook for the number of elements in the union A and B is the number of elements in A plus the number of elements in B and subtract the intersection of A and B. And we can use the second formula for when we know to find a complement of a set. That's just the number of elements in the universal set minus the number of elements in that set. So if I rewrite this to fit our need of the complement of the union, I'm just going to replace A here with A union B. Okay, so let's see what that would look like. The number of elements not in A union B would be equal to the number of elements in the universal set minus the number of elements replacing A now with A union B. So I just want to note that I just replaced the A with A union B. So these will be the two formulas we will use to solve this problem. Okay, so let's see what this looks like. So the number of elements in A union B is going to be equal to the number of elements in A plus the number of elements in B minus the number of elements in the intersection. It is given that the universal set S has 133 elements. Set A has 48 elements. Set B has 94 elements, and here is the kicker. The sets A and B have 30 elements in common, and look at that word and. That means the number of elements in the intersection, because these are the elements they have in common, is 30 elements. Let's go ahead and fill this into the formula. So the number of elements in the union of A and B is going to be equal to the number of elements in A, which is 48, plus the number of elements in B, which is 94, minus the number of elements in the intersection, which is 30. So doing some arithmetic, we get 48 plus 94 minus 30 to be 112. So if the number of elements in the union is 112, then we can easily find the number of elements in its complement by taking the number of elements in set S, the universal set, minus the number of elements in the union of A and B. So the number of elements in set S is 133, and subtracting how many we found in the union, which is 112, we get 21. So the formulas are nice if you are a formula person. And notice this is the answer as well. Some students like to see the Venn diagram, so we can go ahead and do that. I'll draw a Venn diagram down here and see maybe what this looks like. So out here is S, here's set A, here's set B. The number of elements in the intersection we said was 30, which means since there was 48 elements total in set A and 30 of them are shared with B, that means only 18 of the elements are solely in set A only. Using the same argument for set B, since there were 94 elements in set B and 30 of them are shared with A, this means that 64 elements are in solely set B. Great, which means that out here in the rest of the universal set, there is only 21 elements that were not in A or B. And that's what the Venn diagram would look like.